Welcome to YTLS Academy. Today's video is based on novel approach in functional food based on nutrigenomics. So we all are aware of the term nutrigenomics, right? Like nutrigenomics uses the study of how our gene interact with diet, that is we call as nutrogenetics, and how food components affects gene expression, that we call as nutrigenomics, to tailor the functional food to individual need. And we all are aware that functional foods provide health benefit beyond the basic nutrition and are designed to be mechanism to deliver the personalized dietary advice. And if we see its relationship with nutrigenomics, so whereas nutrigenomics provide a scientific foundation for understanding which food or bioactive compounds will be more effective for a given individual. This allow for more precise nutrition intervention to manage the chronic diseases by considering an individual unique genetic makeup and how it respond to specific dietary component. Okay, so see, whether it's nutrigenomics or functional food, they are very useful for human being because they are tailoring the amount of nutrient in a given diet, right? If for example, if someone is having a chronic disease like any heart disease, or a person is having cancer or any diabetic disease, so his dietary plan would be different from others because nutrients are very essential for our body. We all know this, right? But sometimes specific nutrient is there in specific for specific diseases, right? If a person is having any uh, heart related disease, so there the dietary plan would be different. And how we know, yes, this particular person needs this dietary plan because of the nutrigenomics, right? So in this manner, it is helping a person or a patient to cope up with a certain underlying diseases. Now coming back to the definition part, so the definition of functional foods and nutrigenomics, the first one is the functional food. Functional foods are foods that offer a health benefit beyond its basic nutrition. We all are aware of this. They contain bioactive compounds that can enhance the physiological functions or reduces the risk of the chronic diseases. So see, functional foods are again very important for our body. Okay, and it also reduces the risk of the chronic diseases. But actually, what are functional foods? So the foods that have been enriched or modified, means food that have been enriched or modified to provide additional health benefit beyond the basic nutrition is considered as functional food. For example, food, you know, these foods, they can be naturally occurring, like berries, fish, or or sometimes they are processed food. For example, fortified milk, yogurt with probiotics, they are consumed as a part of a normal diet, not as a supplement or drugs. For example, if you see in the supermarkets, there are milk products that are fortified, means there are yogurt in the market that have sometimes they are full of probiotics. Yogurt have sometimes berries flavor, mango flavors, and many others. So what actually it is a product, or sorry, it is a food, but a food with additional uh, nutrient or additional things that are added to it, and they they are enriched in one of the you can say nutrient, and they are very much helpful for human body. For example, taking an example of a probiotic drinks like Yakult, for example, yogurt are very important for our body. Okay, and it gives a good nutrient, it provide good nutrient to for our body. But if a yogurt is coupled with or it is combined with probiotic, so it is a excellent food for our gut health, because probiotics, it supports gut health. Even there are different types of cereals in the market, but when the cereal are fortified with different kinds of vitamins, they are considered as a functional food. Okay, in nowadays eggs are also considered as a functional food. Why? Because there are eggs that are rich in omega 3. So in this manner, as you can see, a food, if you see the natural food, they are again providing nutrition. But if you are adding anything additional to that particular food item, so it enhances its nutritional content in 2x. That is very useful for human body. In this manner, they are reducing the risk of the chronic diseases. So here let us understand one thing about the functional food, that functional food, they have certain characteristics, like they enhance or modified particular food items. They gives nutrition beyond the basic nutrition, means they provide some physiological benefit that improves the health or reduces the risk of the diseases beyond just supplying essential nutrients. Now coming to the third characteristic, if I say, like consumed regularly, means whenever you are consuming functional food, so you should see the change in your health. But again, if you consume functional food daily or regularly, again, one thing I would like to clear it here, that functional food is not considered as a drug or any supplement. It is consumed like a normal diet, okay, but it is not consumed as a supplement or a drug. It is a food that is we consumed in a normal diet. Okay, example we have discussed like probiotic yogurts, berries, fortified cereals with vitamins, even you say whole grains like oats, barley. They are very rich in fibers. They are considered as a functional food. Now sometimes let us understand, here I have mentioned one term, modified. Sometimes when we modify the food, so they are known as a modified food or fortified food. For example, omega 3 fortified milk, okay, probiotic enriched yogurt, iron fortified cereals, foods with added fibers, or okay, sometime. And what are the benefits what the functional food is offering? So they are reducing the risk of high BP, they are improving the heart health, they lowers the cholesterol, they supports our gut health, they reduces the risk of certain chronic diseases, for example cancer. They they reduces the stress. They also gives release from the anxiety reliefs. So in this manner, yes, functional food is very important for our body. Now coming back to the second definition, that is nutrogenomics. As we know that nutrogenomics is the study of how nutrients and dietary components interact with the genome to influence the gene expression and health outcomes. So the basic aim of nutrogenomics, that is to make a personalized nutrition based on individual genetic profiles. We have already discussed about nutrogenomics in our previous lectures, so you can consider that lecture for better understanding of nutrogenomics. But yes, this is the keyword. If I mark it here, that what is the aim of nutrogenomics? So the aim of nutrogenomic is very clear: to personalize the nutrition based on individual genetic profile. This is very important. Now coming to the key aspect. So the key aspect are: identify the gene nutrition interaction. It supports the precision nutrition. It helps to prevent or manage diseases like diabetes, obesity, or cardiovascular condition. Even here one question arises: why we have taken nutrigenomics and functional food together? So like how nutrigenomics, you can say, let us take in the another way, like how nutrigenomic enhances the functional food. This, see, again, the reasons are same: personalized health outcomes, variable responses in the sense, matlab, it explains why some individual may not respond to a functional food as expected. For example, genetic differences in nutrient metabolism can affect the efficacy of the functional food, because every human have different machinery. Every human respond differently to a particular nutrient. Okay, so it also improves the product development also. See, the food industry can use nutrigenomics to develop the functional food that are more effective and better supported by scientific evidences for the health. Okay, so this is how they are linked together. Now, now let us understand the importance of personalized nutrition. So, since from the lecture number one thing is repeated, that is personalized nutrition. Okay, this is the basic aim of nutrigenomics. What is the basic aim of nutrigenomic is? The basic aim of nutrigenomic is to provide a personalized nutrition. Okay, so personalized nutrition is a cornerstone of nutrigenomics and functional food innovation. So let us understand the importance of this personalized nutrition. So the first one is the genetic diversity in nutrient response. So I think we have already discussed this, that every individual, they have different respond to a particular nutrient, and every human being is different from other. That is because of the due to the genetic variation. Okay, so individual metabolize and responds to nutrient differently due to genetic variation. For example, people with the ApoE4 allele may respond poorly to a high fat diet, increasing the cardiovascular risk. So again, the reasons are same, that if a person is if a person, see, every human is different. I will respond differently to a particular nutrient, other will respond differently, because we have a variation in our genetic variation. So for example, when a people with ApoE4, it is a type of a allele, and it is a specific allele, or you can say it provide it is a type of a protein, you can say a protein that can be very crucial for lipid metabolism and transports in the body. So this in this manner, people uh, that have ApoE4 allele, so they respond very differently or poorly with the high fat diets. So in this manner, they are increasing their cardiovascular risk. Now comes the targeted disease prevention. So personalized diets can be very useful when it comes in the prevention or to manage the chronic diseases like obesity, diabetes, or cardiovascular disorders. So what a dietitian or a doctor does, so they tailors the intake of the bioactives, for example polyphenols, omega 3, based on a genetic risk, and it enhances the efficacy. Now if we see the third importance of these personalized nutrition, is to improve the dietary compliances. So personalized plans are more engaging and motivating, leading to a better adherence. Consumers feel empowered by data-driven insight into their health. Integration with digital health. Wearables and AI platforms can track the biomarkers and adjust in the diets in real time, supports dynamic responsive nutrition strategies. So the simple is that these are some importance, but if we look in a um, uh, concise way, so personalized nutrition is very important, because by personalized nutrition, the nutrigenomics can help and tailor the development of the functional food to meet the specific need of different population or individual. So in this manner, this moves beyond one size fit for all advice and make it very precise and personalized, and in this manner they are very useful when it comes to a particular health of an individual. So in this manner, it is very important. Now comes to the role of genomics in tailoring the dietary intervention. This is very important. Okay, so we know that genomics, they tailors the dietary intervention by revealing how an individual's gene influence their response to a nutrients. That enables the personalized strategies for better health outcomes and disease prevention. So this approach, if I say that this approach can help to manage the chronic diseases, for example, diabetes, cardiovascular disease, even it also optimizes the athletic performance, and it addresses a specific issues like gut health by providing recommendation based on a person unique genetic makeup. Nowadays people are suffering from gut health, so in this manner, by the personalized data, so they are helping a person to cope up with certain type of diseases. Now, here one question arises that how genomics personalizes the diet. Okay, see, genomics play a very essential role, a very important role in tailoring the dietary intervention by enabling the personalized nutrition. Already in the previous diet, we have understood the importance of personalized nutrition, how it is impacting our health, how it is very important for our health. So it is enabling the personalized nutrition strategies based on individual genetic makeup. For example, identification of genetic variant. So genomics, it analyzes or analyzes the reveal or reveals the single nucleotide polymorphisms, SNPs, that affects the nutrient processing. For example, variant in the MTHFR genes impact the folate mechanism, guiding folate supplementation strategies. Even it also helps in predicting the nutrient sensitivities. So genomic can identify or predispositions to lactose intolerance, gluten sensitivity, caffeine metabolism. It enables the exclusion or moderation of specific foods to prevent adverse effect. So if we see that nowadays people are suffering from different types of allergies. For example, some peoples are lactose intolerant. Okay, sometimes people are vegans. They are sometimes people need gluten. Okay, gluten free food they want because they have a sensitivity with gluten. Sometimes people have cannot tolerate the lactose. So in this manner, it personalized nutrition or genomics play a very important role for people having these type of sensitivity or health issues. So they are helping the people, and they have a very good impact on person's health, because if we see that disease prevention or its management. So these genetic variation, they can show how an individual respond to a certain nutrient. Okay, so again it will help a doctor or a team to build a personalized nutrition, because it has a good data of a person, that yes, this person needs this kind of nutrient. So they incorporated that nutrient in their diet, and they that diet helps a person to cope up with diseases. Here I have used now two words, that is the gut health and the athlete performance. So yes, gut health. So genomics can help, or you can say identify the dietary interventions such as specific prebiotics or probiotics to support a healthy gut and improves the digestive functions. So in this way, it is helping a person to cope up with the gut health, and yes, optimizes the performance. For example, athletes. So for athletes, what they are doing, it tailors the diet based on the genetic makeup and can help to maximizes the performance and recovery. So athlete, if you see, athlete have different diet plan. Okay, so how the diet plans are made, due by reading their genetic profile, and who is helping this genomics. And in this manner, the diet the you can say a good diet or a diet is given to a athlete, because every athlete are different from each other. So based on their genetic makeup, genetic profile, diets are tailored, and which helps to maximizes the performance and recovery of a athlete. Okay, now let's see the disease risk reduction. So, genomic data helps to target the dietary intervention to reduces the risk of the chronic diseases like diabetes, cardiovascular diseases, and cancer. For example, omega-3 intake may be prioritized for an individual with the inflammatory gene profiles. Now coming to the enhancing the functional food efficacy. So functional food can be formulated to interact with the specific genetic pathways. For example, polyphenols targeting the NF-kB for anti-inflammatory effects in genetically predisposed individual. Now comes the nutrigenomics, their concept and their scopes. Okay, so already we have discussed the definition part, we have discussed the relationship of nutrigenomics with the functional food. We have also discussed the importance of nutrigenomics, and now coming to the concept and what are its scope. So the first is interaction between nutrient and gene. How nutrients are gene interacted. So nutrient interact with gene by influencing the gene expression, modulating the metabolic pathways, and affecting the disease susceptibility. This is the foundation of nutrigenomics. So if one sentences, if someone asks you about the basic concept of nutrigenomics, so this will help you to give the answer. Like nutrient interacts with gene by influencing the gene expression, by modulating the metabolic pathways, and affecting the disease susceptibility. This is the foundation of nutrigenomics. So this is how the interaction of nutrient and genes take place. Now, to further understand more about it, so nutrigenomics, they explores the bidirectional relationship between the diet and genomes. Now let us understand how this interaction take place. So nutrient as a gene regulator. This is again an important, how nutrients, they are acting as a gene regulator. So we all have understood that nutrients and bioactive food compounds can act as a single signaling molecules. They influence the transcription factors and that regulate the gene expression. If we see the example, so omega-3 fatty acid activates the PPAR alpha, which regulate the lipid metabolism gene. So yes, nutrient can be seen or act as a gene regulator. Okay, so at last, if we summarize this thing, so nutrient act as a gene regulator. How? By directly controlling the gene expression. How we control the gene expression? Through transcription factors, and they indirectly influence the metabolic pathway that in turns affect the gene transcription. Again, let us take a very simple example. For example, nutrients like vitamin A and vitamin D and minerals like zinc, they can directly bind to a receptor to modulate the gene transcription, while others like, for example, glucose and fatty acid, they activate the signaling pathway, and in this manner what they does now, they impact the gene that are involved in metabolism and growth. So in this manner, nutrient and gene interaction is very crucial for maintaining the metabolic homeostatic and can have a significant effect on health throughout the life. So again, this is very important concept of nutrigenomics, that how nutrients and gene interact with each other. Now comes the genetic variation affects the nutrient response. This is again important, like single nucleotide polymorphism, that is SNPs. They can influence how individual metabolizes the nutrient. For example, MTHFR gene variant affects the folate metabolism and altering the need of the folate intake. Okay, so in this manner, in genetic variation, they affects the nutrient response. Again, how? By influencing how an individual's body absorb, metabolize and use nutrients due to differences in gene that controls these processes. Okay, now comes to the nutrient gene disease axis. So these nutrient gene disease axis, they refers to a complex, or you can say the bidirectional interaction between the dietary nutrient and an individual genetic makeup. Again, I'm repeating this nutrient gene, what I have mentioned here, this thing, nutrient gene disease axis. So it refers to a complex bidirectional interaction between the dietary nutrient and individual's genetic makeup and the resulting impact on health or disease or the risk of developing the diseases. So this is a field to study, the primarily explore through a scientific discipline of nutrigenomics and nutrigenetics. Okay, so the diet that can upgrade up up regulates or down regulates gene involved in inflammation, oxidative stress and detoxification. So this modulation can reduces the increase or the risk of the chronic diseases like obesity, diabetes and cancer. Now comes to the conclusion part. So we all have understood like nutrigenomics is a revolutionizing the functional food development. They helps in creating the personalized omic driven strategies that offers the targeted health benefits. For example, cardiovascular diseases, diabetes diseases, cancer, gut health. Now the collaboration across sciences, technology and regulation is a key. So that brings to the end of the lecture. I hope this lecture is very you have understood this lecture. So thank you for watching. Follow ITLS Academy on different portal. This is our website, that is www.itlsacademy.com. Thank you for watching. Please do like, share and subscribe. This is our helpline number, that is 7080833450. At last, if you have any doubt, any queries in any of the lecture, please leave your queries and questions in the comment section below. In the next lecture, I will be answering all the queries. Thank you very much.